Hello and welcome to the fourth video of 6 of Elevating Electronics. In this series we are talking about the touch tubes, and in this video, the fourth, we will talk about how you can do something useful with these tubes. So, in the last video, we looked at how you could get this tube actually wired, both in an improper but simple way, and in a proper but not so simple way. But now, how would you wire up, let's say, a relay or something to this thing? Well, we can't actually do it in the simple way of connecting it in parallel or in series, because it's an inductive device, and these touch buttons have a high impedance, so we cannot push that much current through it. So what Otis does is they use a silicone controlled rectifier, and if you see in the schematic here, this is how they actually wired it. You can actually ignore this top part right here. This is just so that they can actually extinguish the tube. The main part here is that basically a silicone controlled rectifier is a special type of diode that, well, I guess it's basically anything's a diode nowadays, but it's a type of transistor, basically two transistors put together in a specific way, and when you apply a small, very small current at the gate, which is great because we can only supply a small current at the gate, we can in turn turn on a larger flow of current through another means, like a different power source, and that's how we actually run the relays using these things. Now, I won't get into specifics of using an SCR with this thing, mainly because I don't have an SCR that can actually handle the type of, the amount of voltage and current we're going to be putting across it. But I can show you how you would connect something in parallel to this thing. So I'll show you how to do that right now. So, in order to show you how this thing actually works, I have a little receptacle here. This one was from another Otis elevator. This is just a simple 6-watt bulb. This one's specifically meant to be operated at 155 volts, 6 watts. So at only 60 volts, and that's what the voltage drop across this thing is going to be. It's going to be around 60 volts. We will only be using around like 8 milliamps through this thing. It's just a guess on my part. So it definitely won't be enough to burn out the tube or any of the resistors on it. So this is just going to be a little show of how you actually connect this thing. It'll be a very dim light, but that's alright. So what do you actually do? Well, is essentially, I show you in the schematic. You essentially connect your load in parallel across the cathode resistor. So this big 2-watt resistor right here. So that's why Otis has supplied us very kindly with these 2 pins here. This pin is for this tube, and this pin is for this tube. So all we need to do is connect our load between the center pin, this black one here, and one of these 2 pins, depending on which one we want to use. So if I want, when I touch this tube, this bulb to light up, all I need to do, is connect a jumper across the terminal, so one there, and connect the other side to the center one, which we can just connect it right there. Same potential, basically. So now we are ready to go. So I'll just turn it on and I'll show you how this thing actually works. So now we will plug it in. Nothing exploded. We'll turn it on. Nothing exploded again. So now it still works as normal, and we can turn on the other one. But now when we turn on the one that our light is connected to, if you look closely, you'll see it's very dim, but there is actually current running through it. Now here's the thing. if you look closely, and we turn on the other one, the light gets a little bit dimmer. And that's because the more tubes we have running, the less the voltage drop across the cathode resistor is going to be. And so in turn, our light gets dimmer. And this is again another reason that we cannot just directly connect a relay to this. Is because if our relay ran at exactly 60 volts, exactly 60, if we put any less, it wouldn't work. And it would work right now, but then when we turn on the other one and the voltage drops, it would in turn deactivate. Thus, the controller wouldn't know that there was actually a call placed there. So again, that's the reason they use a silicone-controlled rectifier. If you want to use a silicone-controlled rectifier, go right ahead, but I must warn you that this is again old technology. Nothing works perfectly when it's old, so if you try and force new technology into this thing, it might work, it might not. Results may vary for you. I mean, it's working fine for me, the light's lighting up fine, but it might not for you, especially if you got parts from an elevator that was meant to be replaced or something. Parts may not work perfectly. But anyway, that's basically how you can get something like a light connected to this. And if you use a silicone controlled rectifier, you could do much more. You could basically do whatever you want with it. So that's this video on how you can wire something up to this to make it do something useful. And in the next video, we will talk about crossfiring, which is probably going to be the most complicated thing that you're ever going to see about these tubes.